Okay, and Fran, if you'll introduce Colin, we can get started.
Well, some of you have already been meeting Colin and hearing about his fascinating life. Um, he is from the Wells class of 2012, and I've known him since before then when he was a student. His is a quite the Wells family. His brother Keegan is class of 2015, and his wife Jessica she's also 2012.
Well, yep.
12, okay. Um, and they're so pro Wells. They've been very active as members of the Fargo board coming up through that, and very active at the Alumni Association. I'm used to seeing them there all the time, and they're so Wells that their baby daughter is named Aurora. And Colin has completed his doctorate at Cornell and has been a research person there at the um, atmospheric science in that field, and has been doing research on climate change. He and I talked about him doing this presentation back, it was kind of it was in the fall, right, Colin?
Yeah. Yep.
And we were really excited about that. And then, of course, we all know about some of the recent events that Colin has mentioned. And so in January, when I talked to him, I said, "Do you really want to do this, Colin? Is it safe for you to do that?" And he said, "I think it's even more important for me to make this talk." And I'm so glad that he's here to do that because I think we could all use a little bit of bucking up and gathering some information because I think we'll be talking to some people over the near future where it will help to be well armed. So, Colin, whenever you're ready.
Great. Yeah. Thank you, Fran. Yeah.
Colin, quick
Yeah.
housekeeping. Do you want questions as they come
Sure.
up? Do you want them at the end?
No, yeah, I would definitely prefer like if this was more of a dialogue and discussion. So, feel free to jump in with any questions as we go along. Yeah, I just want to echo what Fran said is like, I really think continuing to talk about climate change. One is it's the most important thing you can do in the fight against climate change. But more importantly, I was at a summer school a number of years back in Italy, and a very prominent climate scientist was there giving a lecture. And this was during Trump's first term. And uh, somebody asked him, a member of the audience, a grad student, asked him, if you could get a one-on-one with Trump and talk to him about climate change, like what would you say to him? And his response was, I wouldn't say anything. That's not my responsibility. And the groan from the grad students in the audience was very loud. Um, and I think that that speaks to just this divide between atmospheric scientists of a who came up, in a different generation than current climate scientists. Because I often find that younger climate scientists now are much more outspoken, because we need to be, because we are facing attacks on science literally every day, um, and it's important and it's needed. So yeah, so I talked with Fran about what we should talk about, and um, I think if you're gonna talk to folks about climate science, you're gonna come up against the same quote unquote arguments over and over again. I've been doing this a long time, and I've got my responses so canned at this point because you get these over and over and over again. So I wanted to go through a few of the most common ones that I get, talk about what the science actually says, so that you can respond with, some knowledge about like, what it is that's actually happening. And so to get started, just to make sure that we're all on the same page, just a little visualization of that I made of warming atmospheric temperatures over the last almost 200 years, not 200, 150 years. And so as this plays out, as the circle gets further and further from the center, that's warmer and warmer temperatures that we're seeing. And these are average global temperatures from NASA. So these are very well established data. And yeah, as you can see clearly, as we have gotten on in time, we just continue to get warmer and warmer. So why is there climate change? I'm sure many of you, all of you have heard of the greenhouse effect. Without it, we wouldn't have a habitable planet. So on one hand, I am very thankful for our phenomenal atmosphere. It is a, in my opinion, cosmic miracle that we have the atmosphere that we do, that shields us from harmful radiation, that gives us oxygen to breathe. But at the same time, it's delicate. And I think a lot of people don't realize just how delicate it is. It feels huge. But if you were driving 50 miles an hour straight up, you'd hit outer space in an hour. If you drove 50 miles an hour around the equator, it would take you days and days to get there, right? So our atmosphere is really not very big, and we can have a profound impact on it, as we have seen. So why is too much carbon dioxide, the main greenhouse gas that's the culprit for the warming that we've been experiencing? And really what it is it comes down to physics, and a little bit of really bad luck. I'm just going to check the chat here. Okay. In case anybody put questions there. So a few years ago, my PhD advisor, Toby Alt, made this really fun video, just a couple minutes long, and I'll have him kind of explain what's going on here. Maybe. Yes.
I'm Professor Toby Alt from Cornell University, Department of Earth and Atmospheric Science, and I wanted to illustrate the greenhouse effect using a piece of glass, an infrared camera, and a blowtorch. Now, everybody's familiar with the idea that the Earth is warmed up by the sun. Sunlight warms the Earth. And anybody who's sat around a campfire is also familiar with the idea that when you're close to the campfire, you feel heat radiating off of that campfire. That's invisible light. So we're gonna heat up our model planet here, which is made out of metal. It's a metal globe with the blowtorch. We'll give it a nice polar ice cap on top of Greenland as well. And now we can see that invisible light radiating off of our model planet. Now, the greenhouse effect gets its name from greenhouses, which are transparent in the visible wavelengths, but opaque, or actually reflective in the infrared. So in front of our model planet, we're reflecting that light back down. Just like a greenhouse lets in visible light, it's heated, and the long wavelengths have trouble escaping. The greenhouse effect for planets is analogous to what happens if you put on a sweatshirt. By putting on a sweatshirt, I'm now trapping more of that invisible light, that infrared radiation, closer to my body. Makes me more invisible in the infrared. And the greenhouse effect in our atmosphere is to trap more of that long wave radiation, to slow it down as it leaves the Earth. And we experience that slowdown as global warming, just as I experience warming from putting on the sweatshirt. Thank you.
And if anybody's seen the Bill Nye video of him lighting the globe on fire, we we contend that Toby started that first, because he did that a few years before Bill Nye, but that's a good video too. So I want to get just a little bit in the weeds in regards to the climate science, because I think it's really important to understand like what I call kind of the bad luck of our atmosphere. So what I'm showing here are what's called emission spectra. Every object in the universe that has a temperature emits radiation, right? We just saw that with that thermal camera. You saw how bright red Toby's face was. That's because that was the most exposed part of his body, and that was radiating infrared radiation, right? So every object emits infrared radiation in some sort of wavelength. Our sun primarily emits radiation in this visible spectrum. That's why we can see. Now the Earth, on the other hand, emits at a much longer wavelength. Ooh, sorry, let me go back. Between 10 and 20 micrometers. So I want you to remember that this is where the Earth is emitting radiation. So if you went out to space, took an infrared camera, the Earth would glow in the infrared at these wavelengths. This is showing absorption of radiation of different gases in our atmosphere. And I want to highlight some. These peaks, this is at ground level, these peaks right here are corresponding to carbon dioxide. So carbon dioxide absorbs radiation at these wavelengths. And then in the upper atmosphere, almost 100% of the radiation emitted at this wavelength, carbon dioxide can absorb. And if you remember, that's right where the Earth itself is emitting radiation. So the Earth emits radiation, and the gases in our atmosphere are absorbing that radiation that the Earth emits. So that's the problem, is we're adding more carbon dioxide. So we're giving the atmosphere more of a chance to warm up, and we are seeing those consequences. All right, so now we're going to get into some climate myths or arguments that I see pretty often. So this is a big one that I always get. The Earth's climate is always changing. Okay. Literally, not a single climate scientist would ever say that the climate isn't always changing. That's not a slam dunk argument that a lot of climate deniers think it is. That we're not aware that the climate is always changing. Of course, there are natural drivers of climate change. One is what we call changes in eccentricity, which is the shape of the orbit around Earth's orbit around the sun. It gets more circular to more elliptical. So, of course, if you're closer to the sun for a longer period of time, it's going to be warmer. If you're further away for a longer period of time, it's going to be colder. Here's the thing, though. This happens about 100,000 year cycles. Okay, that's important to remember. The next one is obliquity, or the tilt. So Earth shifts kind of back and forth over time. This tilt is what gives us seasons and changes to daylight as we circle around the globe. Around the sun. But again, this happens in 41,000 year cycles. So quite a while. And then we have precession, which is a wobble. So you've got all three of these happening at the same time. This one's the shortest, but it's about 26,000 year cycle. Plate tectonics would be a huge driver of climate over millions and billions of years. So a pretty long time frame. And what goes hand in hand with that climate is always changing comment that I get is, but there were ice ages before, which of course there have been many, many, many times. We've got the beautiful Cayuga Lake to thank for, our ice ages to thank for, our beautiful lake. The problem is that what they're implying is that what we're experiencing now in the climate isn't really a problem. So why is it a problem? What we're seeing here is rising carbon dioxide concentrations. Back in 1958, Professor Keeling started the measuring atmospheric carbon dioxide concentrations atop of Mauna Loa in Hawaii. And they have been taking daily, even sub-daily, hourly recordings for the last almost 75 years. And yeah, as you can see, since then it has been rising steadily. But what we really need to do, though, is put this in a longer context. So prior to 1958, what we can do is take atmospheric measurements from air bubbles trapped in ice cores. So everything before 1958, this is all taken from ice cores from Greenland and Antarctica. Now, I've shown this graph many times, and I've liked that they have updated it with these dates, because people used to think that this straight line was the end of the graph, but it's not. The end of the graph is over here. This straight line is the carbon dioxide we have put into the atmosphere from the burning of fossil fuels. So up here is today. Modern humans showed up here about 300,000 years ago. And so this is the problem. This is an exceptionally unnatural rate of change, unprecedented in the history of our planet. No natural driver of climate could possibly explain that rise, that rapid level of increase in carbon dioxide over the last 200 years. And so that's the problem, is modern humans have never experienced this level of atmospheric carbon dioxide, and the rate of change is so unprecedented. As a side note, unfortunately, the station, the NOAA station that services this observatory, is possibly on the chopping block, which is really unfortunate. All right, another climate myth. This is a actual screenshot of a Facebook comment of somebody that I know. And so it says, so I checked the weather again, 7 degrees this morning at 6:30. It's 14 degrees now. I was looking forward to a little global warming. However, I think I might have to wait till July. I want to thank all the global warming experts for convincing me that 7 degrees is a result of global warming. So if I were to be buried after I die, this would be my headstone. Okay. Weather does not equal climate. I've considered tattooing this across my forehead for the amount of times I've had to explain that weather and climate are incredibly different. So to do a little bit of math, weather, I'm being generous with saying weather's what happens over a day. Weather is really what happens minute to minute. But when climate scientists talk about like the state of a climate or climate averages, we're talking about 30 years worth of information. So when we compare those, one day out of 30 years is 0.009%. To put that in a little bit of context, we cannot make any sort of conclusion about the climate on such a small sample. And an analogy I've started using is saying that if you wanted to determine what happened over the course of an entire professional football season, you would have to look at a 4-inch square piece of the field for 6 seconds. Any 4-inch piece of square, just for 6 seconds, and then decide what happens for the entire season. See what I'm saying? It does not work. You cannot possibly determine what's happening over a climate scale based on one day. I've had some success with this analogy, especially for folks that regularly watch football. I've done one for baseball too, and it's something like 3 pitches of one game determining an entire 162 game season. It's absurd. You just cannot compare weather to climate, especially on one location, one day, on this huge globe that we live on. I think a lot of folks tend to get a little tunnel visioned about where we live and what weather we're experiencing, but it is a very large globe that we live on. And yeah, so one cold day in January, when it's supposed to be cold, certainly does not negate all the warming that we've seen. This is another one that I get very often is, but it was so much hotter when dinosaurs were alive. This is generally my reaction to that one, for a number of reasons. One is we're not dinosaurs, so that doesn't really help us. Of course, there is truth to this. Here we're looking at reconstructed global temperatures over the last 500 million years. And there I've highlighted current average global temperature. And there's the age of dinosaurs. So yeah, absolutely. It was warmer when there were dinosaurs. But of course, there are some problems with this comparison. The Earth looked quite a little different. There were no ice caps, so sea levels were significantly higher. There were vast inland seas. Yeah, it is apples to plastic. I don't know. It's like an absurd comparison. Ocean currents were completely different. Climate patterns were completely different. The atmospheric composition was entirely different. There was way more oxygen, less nitrogen. Carbon dioxide was way higher, right? And that all had huge impacts on what was happening on the globe at that time. So it's really not a helpful comparison. I don't quite understand what they think they're trying to prove. At that point, there were no humans then, so we don't know how to survive in this kind of climate. And yes, carbon dioxide was exceptionally higher at some points. But nothing, like we've experienced or adapted to. So. And then, there's the sea level problem. So I hope you don't like living on the coasts. We can say bye to Charleston and Savannah and all of Florida. New York would be gone. Boston be gone. Los Angeles would be pretty much underwater. San Fran, like, kind of a problem. London is gone. Paris is almost gone. Huge portions of Italy. South America would have these huge inland seas again. And then there's the fact that 40% of the US population lives on the coast. So yes, it was warmer when there were dinosaurs. But the no ice caps would definitely be a problem for all of us. And we already have an immigration issue across the globe. Most of the populations live on the coast. What are we going to do if they can no longer live on those places? Several years ago, the chief scientist of NASA's Jet Propulsion Lab came and gave a talk at Cornell. And he was talking about by 2100, we could easily see 500 million climate refugees being displaced because of sea level rise. It's a problem. The sun. It's the sun, not us. This one's one of my favorites. These are all, I don't know, they've all become kind of my favorite. Just recently, somebody I had posted in my local village group something with climate change, and somebody actually said that climate scientists don't even think about the sun in our work in climate models. And that one really made me laugh. And my response to that was like, that's like telling a cardiologist they don't think about the heart. Like, what are you even talking about? So, of course, the sun is the primary, I put an asterisk, it's complicated, but it is the primary driver of climate and life on Earth, right? Like, we would not be here without the sun. But I can say beyond a shadow of a doubt that the sun is not driving the current climate change that we are seeing. And I can prove that to you with some math. So here this is from NASA, and we're looking at changes in total solar irradiance, how much energy the sun is emitting since 1880. That's this yellow line, versus temperature anomalies in that same time frame. Now, first of all, you can very clearly see that since about the 1950s, the sun has actually slowly been in a little bit of a decline, whereas we have continued to increase global temperatures. But just for the sake of argument, let's take a look at this. So if we took the bottom reading of total solar irradiance, compared it to the high, which we experienced in about 1959, 1960, something like that, that difference comes out to 1.7 watts per meter squared, so energy per area. The change in temperature that would elicit is 0.051 degrees Celsius. Incredibly minute amount. Whereas if we look at the change in temperature over that same time frame, we're looking at 1.5 degrees Celsius. That's 29 times more warming that can be explained by solar activity. So it is not the sun. It just, beyond a shadow of a doubt, it is not solar activity that's causing this warming. It can and has in the past over the course of millennium, but again, it's that rapid change that we're seeing, and it's so unprecedented in the course of our atmospheric history. So another one I get a lot is that it's volcanoes. So here we're looking at fossil fuel emissions versus volcanic emissions. So this green line is fossil fuel emissions, and this purple line, very steady at the bottom, is volcanoes. So it's not volcanoes. The amount of volcanic activity that would need to occur to account for the amount of carbon dioxide we've put in the atmosphere, it would be I mean, take your worst disaster movie, multiply it by 1 million. And that's the kind of activity we would need to see from volcanoes to account for that much carbon dioxide. The other problem that this argument has is that volcanoes actually cool the planet. Mount Pinatubo was a huge eruption in 1992, I think. Don't quote me on that. It was in the 90s. Huge volcanic eruption. And there was actually a tangible dip in global warming for like 2 years. And that's because volcanoes, in addition to some carbon dioxide, primarily the gases that are emitted from those eruptions are aerosols, and aerosols reflect incoming solar radiation back to space. And so volcanic activity actually cools the planet. So again, this argument just holds no water. It's not volcanoes. I've gotten this one more and more, that we're just in it for the money. We're getting rich off this climate hoax. So I asked ChatGPT to make a little image of a climate scientist raking in the money from this hoax. And I think it did a pretty good job. It's actually gotten a lot better. The words are legible, which is kind of scary, but kind of cool at the same time. But this image really made me laugh. I thought it did a great job. But generally, this is my reply when anyone, because several times people have said, you're just in this for the money. So this is my reaction. Please tell me how. How can I rake in the money? Because I still got plenty of student loans and I'd love to pay them off. So if you can explain to me how I can rake in tons of money as a climate scientist, all ears. Now, there certainly are plenty of companies that are profiting off of what's happening. Most of these are investment firms, so BlackRock, Blackstone Group. They sort of bank on climate catastrophe. Certainly State Farm, the insurance company, and this Restoration Industry Association do. They're restorers, right? So anytime a climate disaster happens, they're one of the first to get involved, and they make a lot of money repairing damage after climate disasters. Citadel is one of the most successful, I guess, investment firms in the world. And they interviewed me actually last year for a job. And essentially what they wanted was somebody to improve weather forecasts so that they could better predict the cost of oil, so they could better bet on rising costs. I interviewed for it because I was very curious and I wanted to learn more, because they have an entire team of climate scientists dedicated just to this, and they actually have their own proprietary climate model, which kind of blew me away, because only major research institutions have climate models because they are so expensive to run and maintain and produce. So that should tell you, like, these huge corporations are all well aware of what climate change is doing to the planet. They're not the type of companies to spend money on a hoax. You know what I mean? Like, insurance companies are very aware that climate change is real. So after all that, my best advice for arguing with climate change deniers is simply don't. And I'll tell you why. Most of the time, what I come across are trolls. I'm sure you're all familiar with internet trolls. And there is just no winning against a troll, right? For three primary reasons. One is they use bad faith arguments. They're gonna purposefully manipulate either data or take things out of context to try and trip you up. they constantly are moving the goalposts. Like I run into this all the time, whereas somebody will say, well, what about this? And I'll respond, good question. Here's what the science says. And then they'll say, well, actually, what about this? They'll never acknowledge that you proved their point wrong. They just continue to move the goalpost of their argument. And it goes on forever. And of course, they thrive on attention. So they love arguing with you because this is just what they love to do. So I say, don't argue to convince the troll. It's not going to work. Believe me, I have tried and tried. But what I've come to realize is it's not about convincing the troll, because they're never going to change their mind. But if you respond with facts for the people who might be reading your post or overhearing your argument, that's who you're actually going to convince. Are those people who aren't participating in the conversation, but will absorb what you're saying and actually take that in and maybe then go and actually look up stuff on their own to see what's actually happening. And so this is the strategy after many years of failure in trying to convince trolls that this is why I continue to do it. Because, you know, it used to really drive me kind of nuts that, you know, I would respond with reasoned facts, sources, but it didn't matter because they're not actually looking to engage in a conversation. And it took me quite a while to realize that. And so instead of shifting the focus on trying to convince that one person, I've focused on, I'm not going to convince them. It's going to be somebody else who might be reading that post. And I've found that so far to be a pretty good strategy. You know, I live in a small town with a lot of folks who do not believe in climate science. And I'm quite vocal about climate science. And will often post things about it and get a lot of trolls trying to find flaws in my argument or whatever. And I'll now happily respond because I know I'm not going to convince them, but people do see it and they'll like my comments. And I think that's the important part. Because unfortunately, a lot of times the people who will engage with these posts are trolls. So yeah. So yeah, those are the you know, top 5 or 6, whatever, most common arguments I tend to get from people. If you are looking for solid sources on any sort of climate information, I recommend these different agencies, NOAA and NASA, while they're still there for now. Yeah, and with that, there's my email. If you're on Blue Sky, I've left Twitter for a variety of reasons. You can follow me on Blue Sky. And yeah, so I'm currently at the Northeast Regional Climate Center at Cornell, but only for the next 21 days. I start at Met Éireann in Ireland on June 3rd. So moving pretty soon. And with that, if anybody has any questions or wants to discuss any of this, I'd be happy to.
I think Barbara's got her hand up, so why don't we start with her?
Yeah, I want to say, Colin, this was in terms of making the argument about climate change, one of the best presentations I've seen. And I teach in a senior college, and I've taught a number of courses where climate is at least part of it. I just finished one, in fact. And what I would like to find out, and I don't know who would answer this, is whether once this goes up on YouTube, if I can share this with the people that were in that course. I don't know whether there's a problem with doing that from the former Wells folks or the Learning by the Lake people or not, but some of your graphs, they're just so clear and in pointing out the magnitude of the change. And I love that you brought up the dinosaurs because I remember when back, teaching, I taught high school science for a while, and we would talk about the dinosaurs, and I'd tell them, it was a lot warmer back then. And I said, and they were all the way up near the equator, but it was a lot warmer then. So
yeah, you're talking about massive,
yes,
probably cold-blooded creatures that
yes,
needed a lot of external energy to warm their bodies. Yeah, it
Yep.
had to be hot. We would
Yep.
not survive. Like, we are not meant for those temperatures.
no.
It's like,
So I do have one question. As you look forward, what is your best prediction about how close we are to a tipping point and what will happen when we hit it?
that's a good question. I personally, I don't love this tipping point
Yeah.
discussion, because there's just too many unknowns. There's so much we do know about climate science, and I understand from a media perspective, they like to grab onto this tipping point thing because it's sensationalist, right? Like, it's attention grabbing. That's what creates headlines. There are absolutely certain points where we'll have reach a limit that will shut off something. Like, for example, the Gulf Stream. The Gulf Stream occurs for many different reasons. But ocean currents are primarily driven by temperature and salinity. So if we dump massive amounts of fresh water into the oceans, as we're currently doing because of melting ice caps, it could absolutely get to the point where we change ocean currents. How they're going to change, there's a lot of research being done into that. And at what point and how much water will it take? Those are active areas of research. So it's for me, I find it very hard to say, on this trajectory by 2200, the Gulf Stream will be gone. I don't like doing that. Like I said, mostly because it's just, there's so many unknowns, and I like dealing with things that are verifiable, right? That's the scientist in me. I will say those things, just reiterate, those are absolutely possible. I have some skepticism when folks are like, it's gonna happen by this point. Mostly that's also a practical thing too, is because, well, what if we get to that point and we haven't reached it yet? You know what I mean? And then you lose faith in climate science, which is already a pretty, in the general population, faithless science. So,
Alexis, do you have any ideas for Barbara about how to access this presentation once you get it up on the YouTube channel?
Yes. So again, I want Colin to just, as I like double, triple check that you want this circulated and want this shared, or, if you want it to be public or private or whatever. So that's your call. But if you are okay with it, I can either share it directly with Barbara, or I can just put it up on the YouTube channel. So Barbara, you could either navigate to the YouTube channel, or I could just share the recording directly with you from Zoom.
Whatever's easier for you. I just,
Okay.
to Colin's point about spreading a word that might be heard by people. I think the more people that can see it's nice and short, very succinct, but loaded with good graphics that allow people to understand the what's going on.
Okay.
Invite all your friends to tune in and watch it.
Exactly.
Colin, I don't know if you'll find this encouraging or disheartening, but I spent 45 years career as a structural engineer, and I encountered a similar thing on a very small scale. But I was called by a contractor in Florida to explain why the screened enclosures that they typically put around swimming pools down there were collapsing at a very frequent rate. And I came to find, serious flaws in the structural engineering that was pretty standard for these products. Um, and I felt like I had the cure for cancer, and I ought to be welcomed with open arms. But I found instead I was attacked by trolls. So it was sort of my climate science moment, if you will. I bring it up because I think that with any technical subject, whether it's climate science or structural engineering or almost anything, you find that I don't know, 95% of the population just really isn't going to understand the details and take the time to really understand them. And therefore they can be swayed by any sort of arguments. But not only that, it's just human nature. We all want to go to heaven, but nobody wants to die. You know, we all want our screened enclosures to stand up, but we're not willing to pay for the proper engineering so that they do. With climate science, we all want the Earth to be nice and happy, but we still want to jet to Europe for a vacation. We still want to have 2 children. We still want to crank up the AC, even in places where we really don't need it, et cetera, et cetera, and I think that undermines our common sense, well, our scientific sense, the appeal of science, let's say. And so I wouldn't feel personally persecuted, even though I'm sure you do, and it's easy to feel that way.
Yeah. Yeah, that's a good point because our modern lives are very fossil fuel dependent. And it is hard to ask people to give stuff up that they've become accustomed to. And when people bring that up, my response is, I don't think we need to. And what I mean by that is, I am convinced that we have all the energy we could possibly need. More solar energy hits the surface of the Earth in an hour than the entirety of the US uses in a year. The sun has so much energy. What we do need to figure out is how to harness it. And that's personally where I think a lot of our research and development should go. Solar panels have gotten really, really good. Batteries have gotten really, really good. But there's a lot of room for growth and advancements. And I think we'll get there. The transition point is hard. I often wonder, like, as governments and states, put in place like EV mandates or battery powered lawn equipment mandates, stuff like that. People get really upset because they like what they know. And I think about, like, when cars were coming along, were people really like upset because they didn't want to get rid of their horse and buggy? Or with like trains, you know, like I think it's just human nature to kind of be resistant to change. So I get that to a certain extent. But I think the possibilities for energy are literally endless. The sun's not going anywhere anytime soon. And there's a lot of energy there that we can harness. We just got to kind of figure out and have the will to do it, and have governments that are willing to put in the research, because that's the part that's going to take time. In the meantime, do I think everybody could make changes to help? Absolutely. But I think we'll get there. It's going to be hard, and people are going to suffer because we're slow to adapt to these changes. But I think eventually, I hope anyways.
Well, I heard you on the tipping points, and I very much agree. I think that that's not maybe the way to think of things, or not a preferred way, but nonetheless, I think there's a tipping point with respect to how many humans our planet can support, sustain.
That's just science. That's carrying capacity.
Yeah. I mean, right. That's just a limit, not, and maybe not so much a tipping point as just a limit. And whether it's energy, fresh water, physical space, food, whatever resource you want to hone in on. I mean, because we all exhale carbon dioxide, we're all carbon dioxide machines. Not to mention the billions of us, but not to mention the billions of mammals that we keep to eat. And we're basically driving the wild planet out of existence. And so there's got to be a point at which that doesn't work anymore.
Yeah.
And I almost think we're past that point. But I mean, I'm not basing that on any science, but just looking around. But yeah, I think part of the solution too is population limits. And boy, if you think people don't want to go to electric vehicles, just tell them that there should be less of them, and that's really not going to go over well. So
Yeah.
I don't know.
Yeah. No, you're right. We have there is not a square inch of this planet that we have not impacted in some way. They've found microplastics now in rain. So it's literally everywhere, unfortunately.
Yeah, unfortunately.
Okay, so an argument that I heard, fortunately not one I had to deal with, was wars are good for us because we get rid of people and then we don't have to worry about pollution. I just keep thinking, my father used to say every once in a while, you cannot argue with stupid. And I taught middle science first that I dearly loved. I had parents coming in objecting teaching about seasons the year because that was pagan. So
Say that again, Ruth, because you broke up a little. The parents objected because
parents that complained about teaching about why we seasons because it's pagan.
Sorry, we lost it again.
We keep losing you.
The good part.
I'm sorry.
Yeah, because of what?
I don't know. Maybe I just. Well, I'm probably breaking up just because of where I live too. So
maybe just try shutting your
I
video
think she's
off for a
saying
second.
pagan. Are you saying pagan, Ruth? That it's pagan to teach about where the seasons come from?
Yes.
Wow.
Ah,
That's a new one for me. Wow.
Yeah,
I
anyway,
believe it. I was raised in the South. I believe that.
Yeah.
I'm in England, and there were just a lot of very strange, not everybody, but there would be just very strange things that people would say. Well, for example, wars are good to get rid of enemies, and then there were people that we have to deal with. I mean, sometimes you just take a breath and you take a breath out.
Colin, I saw your temperature blanket from what year was that? 2022?
Yeah.
Yeah, two. For those of you who don't know, it's a thing among fiber artists now. The knitters and crocheters are creating a blanket where you assign a color to each 10 degrees of temperature, and every day you do rows of that, what the high was, that temperature. And Colin did a beautiful one for that year. I'm wondering what your next blanket will look like in 30 years.
Good question. Yeah. Honestly, I'd have to have a new color.
I think so.
Really? Yeah, especially
More.
for upstate New York. We don't, in the 5 years I've lived here, with my weather station, we've never hit above 100. We've come real close.
Mhm.
But absolutely in the next 10 years, we'll have days above 100 in upstate New York for sure. For sure. And that'll just increase.
It's ironic because if I'm remembering correctly, it was the summer of 1976. The high for Syracuse the entire year, I want to say, was 85 or 86 degrees. And I think I might have the year one off or the degree a couple off, but it's basically in that range.
Yeah.
So it's been a relatively rapid rise.
Yeah, it has. And that's the thing too with climate change is like, it's not just these like steady averages that are increasing. It's these extremes that are increasing as well.
Bouncing back and forth, yeah.
I didn't include this one, but like, these huge Arctic air outbreaks that we see that plunge Texas into ice storms. People are like, well, what about global warming? And the answer is that's because of global warming. We're destabilizing this Arctic circulation, and that's what's causing these huge polar vortexes to break up and plunge deep south. So yeah, it's these huge extremes.
I live in Maine and have been actually coming to Maine even in the summers when I didn't live here for 70 plus years. And here in Maine, the Gulf of Maine is warmed faster than almost any other area in the world. And there is a distinct difference that people of my age know about the temperatures in Maine. And I'm just wondering to what degree that kind of anecdotal information can be used to begin to get the point across that this is not something, it's not weather, it is something that has been changing over time. So do you use that kind of anecdotal information or bring it out in people when you talk?
Yes, especially one-on-one, because I love talking to farmers. Farmers are so attuned to what's happening with the weather. And so just not even presenting it as climate change, just asking, what have you seen? Tell me about what it was like when crops were harvested when you were a kid to a young adult to now. Tell me about those changes. And it's a little bit of a tactic to, a teaching tactic, like if you can get somebody to discover something on their own, they're obviously much more like open to it, right? So if you can kind of talk with them just about their personal experiences of seeing these changes. It happens all the time. That people, realize, what, things are different. I mean, I'm about to turn 35. So, I'm still relatively young, but like, even in my lifetime, lilacs used to always bloom right around my birthday, which is May, the end of May, mid end of May. And over the years, they're earlier and earlier and earlier. So that's just something I've anecdotally experienced in 35 years. Another great graphic, if you want to look it up, is they have been tracking the date of the cherry blossom blooms in Japan for the last 1,000 years. It is one of the best, if not the best, like climate proxies we have, observational climate proxies that we have. And you see this, I mean, steady, I can't think of the word I'm looking for. They've been blooming sooner and sooner each year because of climate change. And so stuff like that, I think, really gets through to people because it's something they can experience. And that's hard, right? Like we tend to, I mentioned before, kind of get this tunnel vision of our experiences. And, like when we get a massive snowstorm in the Northeast, it's kind of hard to think about what's happening elsewhere. I get it. But talking about those things that people have experienced themselves is impactful.
Any other questions before we let Colin go? Very much appreciate your work here, Colin, and
It was wonderful.
yeah, we thank you very much. Really, really clear graphics. Great job.
Thank you. My pleasure.
Good luck.
And good luck in
Yes.
Ireland. Yeah.
And don't
good
stay
luck in
way
Ireland.
too long, okay? Come back because we want to
Yeah.
see you, hopefully in Aurora. Our next presentation is the last one for the spring, and we'll pick up in the fall after that. But on Wednesday, May 14th, Kristen Shaw from class of 99 is going to come and tell us. Kristen has been recently involved in a new career path for herself that involves being a professional life coach. And she's going to talk to us something about resilience. And I understand, Alexa, she was getting up with you to try and make that a little more, her presentation a little more interactive so that we all can go through some exercises that'll hopefully be useful to us to build our own resilience, which we are gonna need.
And I say that I love having these learning by the lake opportunities. And I don't know what it will take to continue them, but reach out, whoever is doing the organizing, reach out if you need support or assistance to keep them going.
Well, it's all volunteer, Barbara, and it's people who we know who are leading the kinds of lives that Wells meant for us, fascinating and meaningful. And but we don't know every single person in the alumni body. So any ideas you have about great presenters, please just send me an email and give me some contact information.